Hey, what's going on, guys? So this is going to be section 10.5. It's called secant lines and line segments. So I'm going to do some notes, and then you will also be getting, excuse me, you will also be getting another section of notes today, and it's going to be 9.3, I believe. But this one is 10.5, so I'm going to do this one. So we have to figure out what a secant is first, okay? So secant and I'm actually going to turn off my video. There we go. Perfect. Okay. So a secant is it's a line, ray, or segment that intersects a circle at 2 points. Okay, at 2 points. So we have this circle here. Okay, we have our center E. Okay, and then we have a segment. Oops, not a segment. Oh, shoot. There we go. And here is point A. Here is point C. And then we have an additional segment. There we go. There's a point there. That is D. And we have a point here, which is B. And then we have angle 1 right here. Okay. So we are going to draw AB to form triangle AEB. Okay. So I'm going to draw a dotted line. Okay. I'm going to make that better. That's kind of annoying to me. Okay. Now I have my triangle. Okay. So we know that we have a triangle AEB, so triangle AEB, okay? We know that angle BA to C is an inscribed angle, so inscribed, which means it's inside the not the triangle, it's inside the circle. So the measurement of angle BAC is 1/2 the measurement of arc BC. And then we know the same thing about ABD. So the measurement of angle ABD is 1/2 the measurement of the arc AD, okay? So we have this theorem, okay, it's called the triangle exterior angle theorem. So triangle exterior angle theorem. Okay. And this says that the measurement of angle 1 is the measurement of ABD plus the measurement of BAC. So the measurement of angle 1 can also equal 1/2 the measurement, excuse me, 1/2 the measurement of our arc AD plus 1/2 the measurement of our arc BC. Okay. So in general, okay, in general, we have a circle. Okay, here's our center. And we have a secant here and a secant here. and we have angle 1 here, and this is x degrees up here, and this is y degrees down here, we can figure out the measurement of angle 1 is 1/2 x plus y. Okay, so this is in general. Okay, in general. Okay, so now I'm going to show you guys an actual, or I'm going to show you guys a couple of different cases, okay? So there are 3 cases, okay? There are 3 cases, and I'm going to work them out very quickly. Give me 1 second. Okay, let me get to black. Okay. So we have case 1. All right, we have a circle and 2 secants there. Okay. Angle 1 is right there. Okay. A degrees is this line right there, and B degrees is here. So the measurement of angle 1 is going to equal 1/2 B minus A. Case 2, draw 1. Case 2, we have a circle. Okay. We have a tangent there, a secant there. We have, oh, come on. 2 is here, C degrees is here, D degrees is here. So the measurement of angle 2 is going to equal 1/2 D minus C. And our third case, case number 3, we have a circle. Whoops, that was a really bad circle. We have a circle. No, I don't like that one either. Let's do this one. There we go. And we have a tangent here, and I drew that too long. We have a tangent here and a tangent here. And let me draw in red. 3 is here, E is here, F is here. So again, the measurement of angle 3 is going to be equal to 1/2 F minus E. Okay. So those are our 3 cases. Okay, so we need to watch out for those. All right. So here's an example. Okay. We want to figure out the measurement of angle ABD. Okay, ABD. So here's our circle. Here are the secants, or the secant and their tangent. Okay, so here's D, here is C, here is B, and here is A. And we know that this arc, so the arc of C to D is 139, and the arc of A to D is 151. So in order to find ABD, okay, so we want to find ABD, we got to figure out how much this is. Okay, we got to figure out how much this arc is. Well, in order to do that, that arc is just 360 minus 151 minus 139. Okay, so that gives us 70. okay? That gives us 70. So the arc, so the measurement of arc AC is 70. Now we can find the angle. So the measurement of angle ABD is equal to 1/2. Now this is a case 2, okay? This is a case 2. So we have 151 and 70. So it's going to be 1/2 151 minus 70, okay? Which equals 40.5, okay? So 40.5 degrees. That would be your answer. All right, so this is A. So now I have another example, and this is example B. So we want to figure out the measurement of arc LM, okay, arc LM. So we have our circle. We have our circle there. Nope, I put that point 2. There we go, right there. Have another one here. So we have points here, 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 and here. So this is J, K, whoops, that was a really bad K, K, L, N, and M. So first we need to figure out, oh, sorry, I need to also add what our values are. So this is 34 degrees, okay? This is 3x minus 5, and this is 6x plus 6, okay? So we know that the measurement of angle, let's see, LJM is 1/2 the measurement of arc LM minus the measurement of arc KN, okay? So we have 34 equals 1/2. So arc LM is 6x plus 6 minus parentheses 3x minus 5. Okay, so I'm going to move this 2 over, or this 1/2 over first. So I got to multiply by 2. Multiply by 2. 68 equals 6x plus 6. Now you need to distribute this negative sign. So this is minus 3x plus, because it's minus minus, so plus 10. Or I'm sorry, not plus 10. My mistake. Still plus 5. Okay, 6x minus 3x, so 68 equals 3x, 6 plus 5 plus 11. Okay, we subtract 11 here, subtract 11 there, so we get 57 equals 3x, so x equals 19. Okay, however, we're not done. We want to find the length of the arc length ML, or LM, I'm sorry. So we have 6 times 19 plus 6. So the measurement of arc LM equals 120. Okay, that's how you do that one. All right, now we have one more example. Okay, we have one more example and another thing of cases, okay? So we need to find the value of x. So it says, what is the value of x? So I got my circle here, and I have BD, segment BD, and I have segment AC. I'm going to draw in red. Okay, now let me put E right in the middle. Sorry, forgot that. Okay, so I have these angles are congruent by the vertical angles theorem. Okay, these angles are congruent, and these angles are also congruent. Okay, so we have three angles, okay, but there's a similarity theorem that deals with two angles. So that's the good news. So we have our angle similarity theorem, okay? Therefore, triangle AED is similar to triangle BEC, okay? So based on the angle similarity theorem, we have the length ED over EC, which is equal to EA over EB, okay? Now, E to A is 6, E to B is 4, E to C is 5, and E to D is X, okay? So now that we know our formula, we're just going to plug in values, okay? So we have X over 5 equals 6 over 4. Okay, cross multiply, 4x equals 30. So when we divide 30 by 4, we get x equals 7.5. Okay, x equals 7.5. So then we have three cases, okay? We have three cases when dealing with chord length relationships. That's what that's called. It's called chord length relationships, okay? So I'm going to draw a line here. So here's case one. So we have a circle. Okay, we have a circle. And let me draw. Where they intersect is R, and here is the center of our circle. I'm gonna call it, actually I'm gonna call it P. Okay, let me draw in red. So I have A here, C here, B here, and D right there. Okay, so in this case, A times B is equal to C times D. Okay, AB equals CD. Here is case number 2. So here's our circle. Oops, I drew it too long. Sorry. There we go. The point over here is S. We have our center C. And I have M right here, N right here. Q is right here, and sorry, that looks like a 9. Q right there, and P right here. So if this is the case, you have your sides N plus M times the length N equals Q plus P times the length Q. So it's outside plus inside times the outside equals outside plus inside times the outside again. Okay, that is case number 2. And lastly, we have case 3. So in this situation, we have our circle here. I don't like that circle. We have our circle here. There's our point there. Goes right there. Nope, I drew it too far. right there. There's T. Here's our center C. Here is X. Here is Y, and here is Z. Okay, in this situation, we have X squared equals Z plus Y times Z. Okay, Z plus Y times Z. All right. So those are the formulas. Okay, or I'm sorry, those are the cases that you will need. Okay. Those are the cases you're going to need for section 10.5. Okay. If you guys need any additional help or additional questions, please feel free to message me on Edsby or message me through Remind. I'm going to go ahead and post this, and I will send you guys the YouTube link, I'm sorry, and we will go from there, all right? I will also post section 9.3 notes here in a little bit after I make the video.